Okay, welcome to Systems of Linear Inequalities, tutorial number 3. And so today we are going to look at a graph that represents the solution, the graphical solution to a system of linear inequalities, and we're going to see whether certain points are part of the solution. So for instance, when we see the point 310, we're going to graph it. We know we go over 3. Now, I get it. We're going to go over 3 and kind of get lost, right? But we go over 3, then we're going to go up 10, 1, 2, 3. We're going way, way, way up, even higher. It's not part of the solution, right? 310, no way. It's so far away, I couldn't even graph it on the graph. All right, let's try the next point. How about 5, 1? So we're going to go over 5, 1, 2, 3, 4, 5, and up 1. Perfect. 5, 1 is right here, and it's part of the solution. So that point would be considered part of this solution, this graphical solution. Let's look at 2, negative 1. If we're going to graph 2, negative 1, we'll go over 2, down 1. Oh, that point landed on the dotted line. Now, dotted lines act like a kind of a barrier, like they're keeping the solution in. All the shading, right? The shading stops at the dotted line, but that dotted line isn't part of the solution. It's just holding the shading in. So 2, negative 1 is not part of the solution because it's on the dotted or the dashed line. Let's look at negative 4, 3. If I go over negative 4, 1, 2, 3, 4, and up 3, well, that's crazy. That point is nowhere near the solution. So we only had 1 point out of these 4 that were part of the solution that's shown in this graph. Wonder if, instead of a graph, we're shown the system of inequalities like this. On the test, you're going to see this, and you're going to have to decide whether a point like 4, 1 works for this system. And the only way to find out if it works or not is to plug it in. So the first thing I'm going to do here is I see a y right here. I'm going to go ahead and plug in 1 for y. I see a less than, I see a negative 2. When I see the x, instead of writing x, I'm going to plug in 4. So what I'm doing is I'm plugging the x and the y in, and I'm seeing if the statement left over is true. So let's see, 1 is less than, if I pick up my calculator, negative 8 plus 3 is negative 5. Is that true? Is 1 less than negative 5? No. So that means that this point, switch up some colors, this point, 4, 1, is not a solution. No, it is not a solution because when I plug it in, it gives me something that's not true. So let's try it again. And I realize on your notes, I didn't give you a lot of places to work, and I'm sorry about that. So kind of find a spot on your paper, maybe put an arrow and get some work up there, or somehow find a place to work. Sorry about that. All right, so let's look at this second one. The second point is negative 1, 3, a solution to this system that we see here. So we're going to do the same thing. See how we see a y? Well, instead of writing a y, we're going to plug in our 3. Then we see a less than, so we're going to write a less than. Then we see a negative 2, we'll write a negative 2. So we're just writing everything until, oh, we come along and there's an x. Instead of writing x, we're going to plug in what our x is in this point, which is negative 1. Then we see a plus 3. All right, drum roll. Let's go ahead and rewrite the 3 and the less than. Put that in your calculator and we get 5. Is that true? Is 3 less than 5? Yes. So let's put a check, because we can't say yes totally to this question because it works for the first inequality. Let's see if it works for the second one. So let's switch up. Let's do, I don't know, orange. And let's see if negative 1, 3 works for the second inequality. So I see a y. Instead of writing a y, I'm going to drop my 3 in. I see the greater than. I see a 5. I see the x. Instead of writing an x, I'm going to drop my negative 1 into a parenthesis, then plus 7. I'm going to rewrite the 3 and the greater than, and then drum roll. I'm going to go ahead and put that in the calculator, and I get a 2. Is this true? 3 is greater than 2? Yes. If the point that we're looking at works for both equations, then we write, yes, it's a solution. All right, now we're looking at a graph that represents the solution to a system of inequalities, and they're asking us to name the different inequalities. So there's 4, right? So the first one is this one right here. Number 1, we're looking at the straight up and down line. We know straight up and down lines start with an x. We also know that it's going through -3, so put the -3 on this side. Then we have to ask ourselves, is it a solid or dotted? Well, it's a solid. And is the shading less than or greater than? Can you see that the shading goes this way? So the shading is greater than, so x is greater than or equal to -3 because it's solid. All right, let's switch colors and let's look at number 2. So number 2 is a flat line, and we know flat lines start with a y, and we know that it's going through the y-axis at 3. And we see that the shading from the flat line is shading down. And so, right, this red shading in the middle represents all the different shading that was there where it overlapped. And then all the rest of the shading was erased. Okay? But so the shading is down below the line, so we know that's less than. Because it's a dotted line, we don't put a line underneath here. So this, number 2, represents y is less than 3. All right, let's switch a color. Let's look at number 3. So once again, this is a straight up and down line, and it's dotted or dashed, however you want to say it. We know that this involves x and the number 2 because it goes through the x-axis at 2. The shading is to the left, and that means that all these numbers to the left are less than 2. Because the line is dashed, there's no line underneath. It's just x is less than 2. And finally, let's do this last one in blue. This is line 4. It is a solid line, and it's also flat. That means that it's a y, and the number that it goes to on the y-axis is -2. The shading is up above the line, so that's greater than. So it's y is greater than or equal to, right, because the line is solid. Y is greater than or equal to -2. All right, one last thought. This is going to be a short video. So one last thought is this. Let's look at the point 0, 3. If I were to graph 0, 3, that's 0, and then 1, 2, 3, that's right here. Now this is a tough one to decide if this is part of the solution, because if you can see, and maybe it's not, it's really not obvious here, but it looks like the solution is right here, right? All of this. And then you can see this is a solid line, that's part of the solution, that's a solid line, that's part of the solution. The dotted line is just it's just holding the solution in. It's not part of the solution. So here's the troubling part about this point. It is on a solid line, and the solid line is part of the solution, but it's also on a dotted line, and the dotted line is not part of the solution. So whenever that happens, that's considered not part of the solution. Any other point here, 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 or here, those are all, or even here where the 2 solid lines intersect, those are all part of the solution. But as soon as a solid line intersects with a dashed line that's holding in the solution, that point is not considered part of the solution. So same thing with this -7, -4. Let's go all the way to -7 and down to -4. Once again, because that dot, that point, is on the intersection of the solid part of the solution and the dotted part of the solution, it is not part of the solution. So don't let that trick you. All right, thanks for joining me for this quick video, and have fun practicing.